SpaceX versus F-35? Let's get started. So let's take a look at how F-35 and SpaceX compare and why DevSecOps is a game changer. SpaceX had 200 developers, F-35 at 4,000. We've seen about a 50% 50 defect rate at F-35. That effectively means that 2,000 of these 4,000 developers were useless. With SpaceX, the platform was very modular and flexible. 80% of the code was reused between the platforms. SpaceX has 9 platforms, and F-35 has 1 platform with several variants. F-35 only had 4% of the code shared between F-35 and F-22s. SpaceX was able to do 17,000 build of software a day, 3 hard-in-loop testing a day, and update the software the day before the launch. None of that was possible with F-35, with an average at the time of software update every 7 years. Clearly, this demonstrates the importance of being modular, flexible, and be able to act based on what's happening in the world. I will always remember that trip when we sent our teams to SpaceX to take a look at how SpaceX moves at that kind of pace. And I will always remember looking at some of the senior Pentagon leaders' eyes and see exactly when their brain literally imploded when they started to realize how far behind the DoD was. Unfortunately, many of the Pentagon employees are stuck in time and stuck in that DoD bubble, and they have yet to see what happens outside of it. By sending these people to companies like SpaceX, they were able to see firsthand how innovative companies move and how quickly they make decisions. That's why it's so important to be able to pop that DoD bubble and bring fresh talent in from the commercial side and back. And we must make sure that that two-way street remains open for years to come. Now, why does DevSecOps matter? Well, we talked about the timeliness aspect, both for cybersecurity, but also to be able to compete. Of course, it's the only way to be able to move at a pace of relevance when you also think about the necessary cybersecurity practices that you must have to be able to stay in business. DevSecOps is also the foundation of your digital transformation, including cloud, AI, machine learning, and enables you to have that baked-in security aspect, but also scalability and flexibility. The Department of Defense saved 100 years of time in 1 year by adopting DevSecOps with 27 programs. I argue that we didn't just save 100 years, we just didn't waste it. Because guess what? China, Russia, and North Korea are not waiting for us to figure this out. DevSecOps also enabled us to bring hard-in-loop testing and continuous integration, continuous delivery, and testing at the edge in real time, multiple times a day. Okay, so if that wasn't enough to convince you, let's take a look at some of the numbers. We've seen 106 times faster lead time from development to production. We've seen 208 times faster code deployments, 7 times lower change failure rate, 22% less time spent on unplanned work or rework, 50% less time spent on fixing cyber issues, a mind-boggling 2,600 times faster lead time to recovery, very critical when it comes to weapon systems. We've seen development costs reduced by 40% on average, faster prototyping with 44% more time focused on new capabilities versus maintaining legacy code. More importantly, if like everybody else you're having a tough time retaining and attracting talent, we've seen a 2.2 times employees being more likely to recommend and also remain at their organization. In 2019, Kubernetes and Istio, the service mesh, were put on the F-16 jet in 45 days on the legacy hardware. In 2020 and moving forward, Kubernetes and Istio are now the default. We took the U-2 jet, which are 60 years old, and we're able to deploy the DoD DevSecOps platform using Kubernetes and Istio on the jet in 12 days, build AI and ML containers to automate the management of sensors on the jet so the pilot can focus on something else. And we were able to fly the jet and update software over the air with no impact to the airworthiness of the aircraft. So let's take a look at the DevSecOps layers. We cut them in pieces so they can be swapped around, and more importantly, we want to be able to run software across all the layers on different platforms, whether it's on the jet, bomber, space system, or on the cloud, whether it's classified cloud, on-premise, hybrid, doesn't matter. So first, we separate the infrastructure layer. We put Kubernetes on top using different kind of distributions to give options to different teams, and we're able to completely containerize the continuous integration, continuous delivery pipeline with about 1,000 containers as options, so you have multiple tools and different capabilities based on the mission needs. On top of that, we deploy the service mesh. We use Istio in DoD to be able to enforce zero trust and mutual TLS tunneling and enforcement with whitelisting. We use the concept of a sidecar container to inject that reverse proxy of the service mesh, but also capabilities to centralize logs and telemetry and be able to enforce a lot of the continuous monitoring stack that we have baked in as well. What you see on the top is the application layer, which is often microservice driven, of course. And the beauty there is that that application inherits about 90 to 95% of the NIST 853 controls. There you have it. F-35 versus SpaceX. And we've seen DevSecOps is not only a massive enabler, it is indeed the game changer for your velocity and baked-in security.